Welcome to the Inland Empire Utilities Agency Water Quality Laboratory. My name is Milena, and I am the laboratory assistant here at IEUA. Today I will be giving you a short tour of our lab while also giving you some insights to our daily routines and how we fit in here at Inland Empire Utilities Agency. It all begins with a sample. Every day, the IEUA lab receives up to 50 daily samples. These samples are generously provided to us by our groundwater, operations, and pre-treatment staff. All samples brought into the lab must be clearly labeled to match their proper documentation and must be stored and preserved according to CFR guidelines. When receiving a sample, it is imperative for the lab assistant to ensure that proper documentation is correctly filled out and matches all samples being brought in. It is also the duty of the lab assistant to ensure that all samples are brought in their correct bottles along with their proper preservatives. Once verified, the sample can now be logged into our Laboratory Information Management Systems, or LIMS. All information regarding the samples, such as site, date, time, and collector, will be entered into LIMS. Most importantly, the analysis required for these samples will also be entered into LIMS. LIMS will then generate a sample order ID for each sample and a label that clearly marks the order ID along with the analysis required. Once the lab assistant checks for proper preservation, she can now distribute the samples among the lab staff. This is a microlab. Here we analyze samples for coliform for our regional plants. The lab scientist too must aseptically prepare the sample to avoid bacterial contamination. Once prepped, she will then transfer the sample into the quantitray using aseptic techniques. The IDEX Quantitray Plus seals the tray with the sample inside. Once fully enclosed, we incubate for 24 hours. After 24 hours, we remove the sample from the incubator and look for any color changes which can indicate the presence of coliforms. Here at IEUA, a bright yellow color indicates coliform bacteria is present. After we record our results, we place used quantitrays into the autoclave to sterilize before disposing. All coliform results will be reported directly to operation and lab staff to verify that we are meeting our daily NPDES coliform requirements for wastewater. In our bioassay lab, we perform toxicity testing as per EPA method for our effluent wastewater discharge. We conduct a 7-day static renewal test, which lasts for 7 days using Cereodaphnia dubia as our test organism. Each day we expose Cereodaphnia dubia to an effluent sample to determine if the sample is suitable for organism reproduction and survival. IEUA uses Cereodaphnia dubia as our test organism because its reproductive sensitivity allows us to detect lower level toxicity. The boards shown here are called brood boards, which we use to keep our in-house culture. These boards allow for continuity of the toxicity analysis month to month. This is an adult Cereodaphnia dubia. As you can see, she is expecting, and we will be using these neonates to initiate our bioassay test. As the lab assistant makes her way through the lab, she will store some samples for later use and distribute others directly to the lab scientists, as they have a much shorter hold time and need immediate attention. It is a responsibility of the lab assistant to inform all lab scientists of any short hold times to ensure that no samples are missed. This is our wet chem lab. It is the backbone of the IEUA Water Quality Laboratory. Here's where we perform a variety of tests to ensure every step in our wastewater treatment is functioning properly. Lab scientists use instruments such as this flow analyzer to detect if ammonia is being removed from the effluents to the effluents. The lab has its share of hazards, and on top of proper protective equipment, we have additional equipment to make sure that we are safe, such as these fume hoods, to protect us from coming in direct contact with hazardous chemicals, such as chloroform when we are looking for surfactants in groundwater. One of the perks of working in the wet chemistry lab is having an amazing view of our Chino Creek wetlands. Another perk of working in the wet chem lab is having the ability to learn how to troubleshoot and perform maintenance on your instruments. Our lab scientist is currently troubleshooting our ion chromatographer. Operations rely on this analyzer to detect if our denitrification process is converting ammonia into nitrates and nitrites effectively. It is also very important to keep our clocks up and running, as some sample analysis must be conducted within the first 24 hours of sampling. Therefore, it is imperative that we keep all time limitations in mind. These TOC detectors allow us to determine how much organic food is coming into the plant and if our biological systems can properly process the organic material without overloading the treatment process. Along with all of these amazing instruments, let's not forget the most important one, our scientists. For certain analysis, such as solids, we become the instruments, filtering our samples through special lab equipment. Using these ovens, we completely dry the filtered samples and calculate the results for operations to use in different treatment points. This is our metals lab, where we test for metal contaminants in our wastewater and drinking water. Our laboratory scientist too prepares a variety of calibration standards for our ICP instruments to analyze our samples. Inductively coupled plasma, or ICP for short, is an ionization source that will ionize metals in a sample into its elemental ions. The ICP instrument will create a plasma that ranges in temperatures of 6,000 to 10,000 kelvins. This plasma allows for the metal ions to enter a state in which they can be identified and properly quantified. Knowing the concentration of metals in water is an important part of the lab, as it helps us determine if we are in compliance with our reporting agencies. This is the organics extraction section of the lab. This is where we extract the target compounds or analytes from the samples we receive. The extraction process removes the analytes from the samples which contain impurities. It also places them into a chemical solvent that can be easily analyzed by our instruments. Reducing the number of impurities also allows for more accurate results. When there are more impurities in the samples, it can mask our target compounds, making it more difficult to identify them properly. We can also increase sensitivity by taking a 1 liter bottle and concentrating the sample into a 1 milliliter vial in the proper solvent. By concentrating the sample into a 1 milliliter vial, we are essentially able to have 1,000 times higher sensitivity. Once extracted, the sample will be brought into the semi-volatiles section of the lab. Here is where we take the extracted compounds and analyze them. These high-tech instruments will help chemists identify and quantify the analytes we are looking for. Although the target compounds have been separated from the impurities and interferences, they must now be separated from one another to properly identify them. For instance, one of our routine analysis performed by this instrument detects up to 70 compounds from this 1 ml vial alone. However, this vial can contain other organic materials that are not in our target list. If we were to analyze the extract without separating the target compounds from one another first, we would not be able to accurately identify the compounds. We separate the target compounds in a process called chromatography. This process will separate compounds by allowing them to interact with a column. The analytes will move down the column at different rates. Once these compounds leave the column, they encounter the detector, which then releases an electronic signal. The intensity of this signal will allow us to determine the concentration of the target compounds. Here is a simple picture that describes chromatography. As you can see in this picture, each color is a different compound. Without separating these peaks, we cannot properly identify the compounds. IEUA's Water Quality Laboratory recently acquired this liquid chromatography triple quad instrument to analyze for PFAS. PFAS has been linked to a wide range of health issues in humans, from low birth weights, effects on immune system, cancer, and thyroid hormone disruptions. This is IEUA's first LC and triple quad, giving us more versatility on what types of compounds we can analyze. The major benefit of having a triple quad is higher sensitivity and more selectivity. With this new technology, we can now see potential compounds that we could not see before, giving IEUA a huge advantage to catch and monitor these compounds. Organic and volatile samples are stored in our walk-in fridge as they require more space due to their large volume. All samples stored in this walk-in fridge must be stored at 4 degrees Celsius at all times. Laboratory staff must check the temperature of this walk-in fridge along with other temperature-sensitive equipment throughout the lab twice a day. This walk-in fridge also stores already analyzed samples for up to 3 months at a time. This is to allow lab staff to reanalyze any sample in case of instrument failure. Once a sample has been properly analyzed and reported to our compliance department, it can now be properly disposed. Joining us on our lab tour today. We hope you enjoyed the tour. Please gather all of your belongings and exit to the door on your right. Bye-bye. Gracias por acompañarnos hoy en el recorrido del laboratorio. Por favor, reúne sus cosas, cuide a los pequeñitos y salga a las puertas a su derecha. Bye-bye.